I'm Ashton Addison from the Crypto Coin Show, and today on Blockchain Interviews of Muriel Médard, co-founder and CEO of Optimum, here to talk about blockchain data propagation, why propagation is the scaling ceiling for everything above it, and the roadmap for blockchain adoption and what comes next. Muriel, welcome to the show, and thanks for taking the time.
Ashton, it's a pleasure. Thanks for the invitation.
Yeah, blockchain adoption is growing faster than ever, especially with institutions and enterprises getting involved, as well them waking up to AI and now realizing the synergies between AI and blockchain. And some blockchains might not have that scalability ready for this mainstream adoption and all of the other factors. And I know that you've been studying this for a long time. I'd first love to hear a little bit on your background and how you got involved in this aspect of blockchain and adoption. Then we can dive into Optimum.
Yeah, thank you. I'd love to do that. So as you mentioned, I'm CEO co-founder of Optimum, and I have spent my career until then at MIT. I'm a professor there in electrical engineering and computer science. I hold the NEC chair in software science and engineering for the School of Engineering. So obviously have been extremely technical my whole
Mm-hmm.
life. And I've been leading the network coding and reliable communications group. The network coding and reliability, we're going to go back to that during our conversation because that's really key
Mm-hmm.
in what Optimum is doing.
Mm-hmm.
Um, and for pretty much my entire academic career, I've been looking at what was at first just a deep, almost philosophical curiosity. Um, but I think this will resonate a lot with our listeners who are, blockchain either enthusiasts or at least curious.
Mm-hmm.
And the questions are following. Can you do as well in a decentralized system as in a centralized system? Yes or no, right? I mean, that's like a really fundamental question. And, it's not about what you would prefer. You might philosophically
Mm-hmm.
be more comfortable with something decentralized or not, right? It's
Mm-hmm.
just, a very key question.
Mm-hmm.
Um, and for the aspect of propagating data, of actually communicating data from, a set of apps, sources, whatever you want to call it, to, a set of um, machines, users, whatever it may
Mm-hmm.
be, who want that data. The rather surprising question is the decentralized system does as well.
Mm-hmm.
Uh, and in many ways, actually does better for the following reason that in a decentralized system, you don't need to keep track of state. Um, right. I mean, if you're talking about centralization, you're talking about having one really powerful entity that's then figuring out exactly who does what and sending out instructions. And that doesn't work. That doesn't scale.
Mm-hmm.
Um, and so it has been, a key interest. You can see why it's super interesting. Again, it's a fundamental question. And then, one answer is just to say, no, actually, you don't have to go for centralization in order to have optimality. Um, that's actually in our name, Optimum. But on top of that, it can be done really easily, right? So it's one thing to say, well, in theory, they should be the same, that's maybe interesting, but okay, it stays as a curiosity. It's another thing to say, actually, not only can you do as well or effectively better, but it's very practical to do so.
Mm-hmm.
And basically, that's my background.
Mm-hmm. Yeah, definitely. It does get technical, especially when people are just getting involved in crypto, Bitcoin, and Ethereum. Maybe they've heard of propagation from websites and traditional coding, but once you are rebuilding the entire financial system and monetary system into tech, it's like, oh God, we got to get this right.
That's right. Yeah, that's right. And it's very much like something like urban planning, right? You could say, okay, I need more housing. I'm going to put all these buildings. But then, if you don't have the infrastructure and the
Hmm.
roads,
Hmm.
you build these buildings and then people are saying, well, I don't want to live there because
Hmm.
I'm stuck, on
Yeah.
the road for hours trying to get to work. This is, what's the point in adding more apartments or whatever it is, I don't have the public transport or the roads or whatever it is to actually
Hmm.
use them.
Definitely. That's a great analogy. And with the current case of some of these mainstream blockchains that most people are familiar with, it seems like the roads, they're there, but maybe they're not superhighways.
Yeah, they're not super highways, and basically, there's also an issue of, are you even using your roads as well as you could,
Mm-hmm.
right? So is it that you really would need to put in a ton of money and build lots and lots of new roads? Or is it that you basically, the timing in your red lights is completely off and you're creating traffic jams all over the
Mm-hmm.
place for no good
Mm-hmm.
reason, right? Like, um, and it's basically the difference between, going in your pocket and potentially having to put out a lot of money and then, having to maintain those roads, it's really expensive.
Mm-hmm.
Or saying, well, why don't you start with doing the traffic engineering correctly,
Mm-hmm.
Um, and what we're doing is we're doing, if you will, the traffic engineering. The difference between what we do and physical roads
Mm-hmm.
is that we're talking about data, right? So we're talking about numbers.
Mm-hmm.
And you can take numbers and you can manipulate them. You can do different representations of these numbers. You can't do that with physical
Mm-hmm.
cars or trucks or
Mm-hmm.
whatever, right? You can't go, well, I'll take a sum of this truck and that car and see what happens, right? Um, so it's basically saying, why don't we do things that intelligently leverage the fact that you're using numbers, and that numbers are very flexible, wonderful entities, that are going to allow us to represent data in a much more efficient fashion.
Definitely. I'd love to dive into the use cases for blockchain with this technology. Is this primarily just for money transfers, as we've seen, like sending Bitcoin from one person to another, or tokenization of stocks, or like decentralized applications? Does this really cover everything, or uh, are there specific use cases for having the propagation set up?
That's a really excellent question. Thanks, Ashton. So the it's extremely versatile, as you've just hinted. That this comes in so many ways, in the same way that transportation in our life comes in so many ways, right?
Mm-hmm.
And they're the ways when we experience it ourselves. Like I get in the car and I'm trying to get somewhere. That would be like the user trying to basically, do a transaction on Ethereum, for
Mm-hmm.
instance. And then there's also the indirect ways that we experience it. The transportation is basically behind the whole supply chain. So, I may see that my goods are more expensive, or that I go to the shop and I don't have what I need when I want it, or, it takes forever to get something delivered. That's because, I may not experience it directly, but everything that I do is effectively reliant on a supply chain that lives on top of the
Mm-hmm.
transportation network. It's the same thing with blockchain, right? So our first go-to-market has been going more to the people that actually make the blockchains work, the real engine behind the blockchains, and that's the validators, right? So the validators are not entities that users are interacting with directly, but
Mm-hmm.
they're entities that users are crucially dependent on.
Mm-hmm.
So they're the ones that are doing the work of validating, as the name indicates. And they have, of course, a really crucial dependence on propagation because they have to talk to each other, right? I
Mm-hmm.
mean, all of consensus relies on the fact that to reach consensus, you need to talk to people, you need to send data to people, you need to hear back from people. And that's happening through this propagation network.
Mm-hmm.
Um, so in a way, it's if you think, if the transportation network was, a complete disaster, probably the first place you would see it is in how you could access the goods you need.
Mm-hmm.
You would, of course, see it in your own, personal experience with the transportation network, getting to from work, school, whatever. But you would experience it probably in even a more radical fashion with respect to, hey, I went to the shop and there were no vegetables,
Yeah.
because they couldn't get there on time.
Mm-hmm.
So that's been our go-to-market, but basically everything relies on having good propagation. And now, if you're talking about blockchain, the propagation is decentralized, right? Um, by its very nature, you have a system which is as uh, not dependent on geography as possible,
Mm-hmm.
right? And one approach that people have taken sometimes is to try to decentralize everything. But then you can ask, well, why are you doing blockchain, right? If you're just putting all the machines in one room,
Mm-hmm.
how is that different from having a single machine?
Mm-hmm.
Would you really call that blockchain? What is the reliability aspects there, security, trust? You're basically just pretending to talk to different machines. And while they may be physically different machines, effectively they're not. They're all in the same room under the same
Mm-hmm.
control.
Great. And looking back at Ethereum over the years, they spent many years with one consensus mechanism and then switched it to the proof of stake, which many said was sort of like the analogy was changing the engine of the plane while it's flying and hoping it doesn't crash. So, how has that journey with setting up the consensus and the propagation properly with Optimum from the beginning been so far, and where is it at right now?
That's a great question. Thank you so much, Ashton. And I think that that phrase from the Ethereum experience is perfect. You don't want to be changing engines on a plane. That's really
No.
scary. So we don't touch the consensus part at all. That's really the core of these L1s, how they do the consensus, what kind of proofs they rely on. And we are simply trying to change uh, the propagation, and also we're trying to change it in a way which is supplementary,
Mm-hmm.
not we're not yanking anything out.
Mm-hmm.
What we sometimes say is we take a Hippocratic approach to networking, which is first do no harm. It's not
Mm-hmm.
like, oh, I'll do this, but yeah, it might not work out. No, I'm not going to do anything that leaves you worse off than before.
Mm-hmm.
And I think that that's key. So what we do is we have a system which we call P2P. So some of our listeners may be familiar with P2P, but I'm sure to many it's a new terminology. P2P stands for peer-to-peer and is actually the mechanism by which systems like Ethereum, but by no means is Ethereum the only one to do this, do the data propagation that we mentioned before. And what we're doing is I mentioned at the beginning of our conversation that I lead the network coding and reliable communications group at MIT. So we use network coding, and in particular, a decentralized way of doing network coding called RLNC. Again, putting a pointer to some of what we chatted about earlier on, I talked about the fact that, we're not sending cars, we're sending data. Data is
Mm-hmm.
malleable, it's numbers. So what coding means is actually making equations. And what we do is we make these equations in a decentralized way in the network.
Mm-hmm.
So those equations basically propagate the data optimally. And what we mean
Mm-hmm.
by optimally means you could not have done this faster, right?
Mm-hmm.
And it's not often that you can have mathematical proofs of doing better than anybody else. But in this case, we do have those proofs, which is, kind of mind-blowing when you think about it, that you can do that, So often we say optimize when we just mean improve. And here what we say optimize, it means actually, you
Mm-hmm.
know, like Webster definition optimize. Like
That's very cool. And I was reading into through Optimum beforehand, and I saw, the major competitive advantage, this RLNC,
Correct.
random linear network coding. So that's really the secret sauce. I'm not sure how secret it is, but to the decentralized approach for getting things done as fast as possible.
That's correct. That is correct. And I think, it came out of my lab. I'm a co-inventor on the technology. Um, when we first put it out there, I mean, we got so much pushback, and the notion was you must have made a mistake in the math. There's no way you can do this in a decentralized fashion randomly and get the best throughput. Like,
Mm.
there's no way. You should be able to do better if you had some control, and the answer is like, well, read the paper. Now, to be fair, the early papers were pretty turgid. Uh, my fault, I get it. They were pretty turgid. Um, and so even though they won all kinds of international awards because people are like, wow, this is amazing, I realized that many people didn't read it or didn't read past the
Mm.
first 2 or 3 pages, and I don't blame them. But actually, the concept by itself um, is pretty simple, if you will, even though the reasoning of why it works may be counterintuitive. And if you want to do it in a very precise way, it can be quite involved.
Mm-hmm.
It's basically, let's go back to this data we talked about, the numbers. Numbers are variables, right? If you knew what the numbers were, they wouldn't be variables. You wouldn't have to tell anybody. Yeah.
Mm-hmm.
So for me to send information to you means that there's some variables you want to know, Ashton. We're going to call the variables X, Y, and Z.
Mm.
And, the information is out there in the network. Um, and traditional systems like P2P that I mentioned, what they do is they'll be sending these variables around. And here's the problem. Uh, if you want to have everything centralized, you might say, okay, Ashton, I have XYZ. I'm going to send X along this particular path to you and Y along this particular path and Z. And if it doesn't get there on time, somebody's going to tell me they didn't get there on time. And then I'm going to transmit Z
Mm.
again. And, we'll do some really complicated, centralized, optimal, you know, crazy schedule for you. Um, Alternatively, if you want to do this in a decentralized way, what P2P does is it say, well, I'm going to send multiple copies of XYZ,
Mm-hmm.
and eventually you'll get enough copies that you'll get XYZ. Here's the problem. Because I don't know exactly, it's decentralized, I don't know exactly when you're going to get X, when you're going to get Y, when you're going to get Z. Let's say, well, let's say I'll send you 3 copies of each. All right,
Mm-hmm.
great. Um, and now you're sitting there and you get maybe 2 copies of X, 2 copies of Y. So you got 4 variables, but you still
Mm-hmm.
don't have Z, and you really need Z.
Mm-hmm.
It's like this is, as we talked about, a lot of this is financial data. It's not like, oh,
Mm-hmm.
well, that's good enough. It's like, no, I like, like, you know, you're doing a transaction and you're like, was that a plus sign or a
Mm-hmm.
minus sign?
Mm-hmm.
I really need this
Yeah.
variable to tell me, I'm not going to just get started and hope for the best. So basically what happened is, you only needed 3 variables. You've used, you know, 4 units of data, basically 4 variables, right? So you have already used whatever 33% more than what you
Mm.
needed in terms of bandwidth, and you still don't have what you need.
Uh-huh.
And then, eventually you'll get Z, but by that time maybe it's like the fifth thing that you receive, you're like, okay, this wasn't very efficient.
Mm-hmm.
Um, and if you go, well, I'll just keep sending more and more copies, you just clog everything up,
Yeah.
right? So, we go back to this example with the physical network, and you go, well, my deliveries are not really
Mm-hmm.
very reliable. So
Mm-hmm.
what I'm going to do is I'm going to go and order, my coffee capsules, like, one from Amazon, one from
Mm-hmm.
Target or whatever. And then I'll get the one that I receive first. And then you've got all these, well, coffee capsules at least keep, but imagine if it was your groceries, right? Like,
Yeah.
okay, I just wasted a lot of money just because
because
I really needed it tonight and I wasn't quite sure which one would come first, right?
Yeah.
Not a good idea.
No.
Um, so the idea is we then instead create equations. So now you get one equation with XYZ, another equation with XYZ, a third equation with XYZ, and you go, okay,
Mm-hmm.
I've got three unknowns, got three equations, done,
Mm-hmm.
all set,
Mm-hmm.
you know. And therefore you don't need to send a lot of equations to try to make up for the inherent unreliability that you get in a system. The approach that you could say is like, well, why don't you send them to me directly? But, the world is huge,
Mm-hmm.
right?
Yeah.
And, so one of the things that I've done a lot is gone to like kindergarten classes and try to teach about networking. And one of the
Mm-hmm.
first things I always tell the kids, okay, you need to have some yarn, make sure you have some yarn. And then, I show them how networks work. And, first you have two kids and you connect them with one piece of yarn. And you're like, okay, great. So whatever, Bob is able to talk to Ahmed or whatever, and then you add Susie, and then, okay, you put three pieces of string. That's okay, everybody. And then you take more kids, and, the whole thing looks like a plate of spaghetti, and they're like, that's not going to work, right? So,
Mm-hmm.
you can't have direct links from everybody to everybody because, there's a lot of people, and it grows with the square of the number of people. So, uh, so you need to have a network, it
Mm-hmm.
needs to be the sort of messy world that we have. It's again like if you were in roads and you go, oh, it's taking me a long time to get to work. I know what, I'll make a road from me to my job directly, like, and everybody's going to do that.
That would be great.
It'd be great, but you can see the cost,
Uh-huh.
right?
Yeah, definitely. So with this technology, you know, there's a huge network effect on
Yeah.
what we've built so far with blockchains in general, and new technology keeps evolving. Is this something that the current blockchain infrastructure can take advantage of, or maybe compatibility to port things into the Optimum network? How can we build on what's already been built?
That's a really, really good question. I think this gets back a little bit to the theme you were saying about trying not to change engines in flying airplanes, right?
Mm-hmm.
And the FAA wouldn't approve, and neither would the
Mm-hmm.
passengers.
Mm-hmm.
So what we do with respect to, existing blockchains, we've started on Ethereum, but we're already starting to migrate to other blockchains, is we work with the infrastructure that's there and then just put a network system that's additive to that, just improving on that.
Mm-hmm.
Um, but again, very much with respect for what's already been built, what already works, and what people are relying on.
Mm-hmm.
Um, for new blockchains, can't disclose, but we're in some conversations there. Of course, you can say, hey, look, why don't you do this from the start?
Mm-hmm.
It will be smoother and it will save us the trouble of having to, um, you know, ensure that backward compatibility with a non-optimal system and just adding to it.
Mm-hmm.
So that has been our approach with respect to existing blockchains, take what's out there and just improve it without breaking anything, without removing the plane engine, maybe if you will, adding a booster to it rather than,
Yeah.
yanking it out. But now you go, hey, look, if you're going to start from scratch, you
Mm-hmm.
should just do it
Mm-hmm.
right.
Definitely, I agree. Earlier, you were talking about the validator network and the importance of it, in that the decentralized nature of it through
Yeah.
geography and making sure that it's optimized for speed and transactions as well. It's always a balance. I
Yeah.
saw there's this thing called Flexnodes with Optimum.
Yeah.
Is that
Yeah. Yeah.
how can people get involved? Like, for example, you've never mined Bitcoin or you don't have a AWS server knowledge. Is that something that more regular people can get involved in, or how does that exactly work?
Absolutely. Yes. Yes. So that's another great question, Ashton. So let's go back to this notion of these equations, right? So basically, the idea is that what we do is we're doing this data acceleration network by the transmission of equations. Um, Anybody can help in sending equations, right? You're taking equations from the network and you're pushing equations in the network to help other nodes.
Mm-hmm.
Um, from the point of view of, say, let's start with the cost of the machine,
Mm-hmm.
it's very low. Like,
Mm-hmm.
my laptop right now is more than enough. It takes, about half a CPU does the trick. And, unless you're doing something pretty intense on your computer, half of your CPU usually is idle,
Mm-hmm.
right? Um, from the point of view of bandwidth, whatever you send is helpful.
Mm-hmm.
So it doesn't have a gating factor where you say, you need to send me at least this much, otherwise I
Mm-hmm.
can't use it. It's really something that's, anything that you can do is helpful. And then the other aspect is the uptime. So, as you said, if you're going to mine Bitcoin, or if you can run, if you're thinking of, say, running a validator
Mm-hmm.
on
Mm-hmm.
Ethereum or Solana, whatever, it's a big investment.
Mm-hmm.
We mentioned the compute, you need to have very stringent requirements on your machine. Of course, you need to stake, and some chains require you to put a lot of investment in the staking, but you also need uptime.
Mm-hmm.
And that uptime can be really challenging, particularly in certain geographies where you're like, I don't have that kind of uptime.
Mm-hmm.
I was talking to somebody who runs validator nodes for Ethereum, from home, and he was telling me he has three ISP connections, and then he has to kind of like, he one of them is basically just there for backup, and then he does some clever,
Mm-hmm.
you know, merging of the
Mm-hmm.
two first ones to get the full bandwidth. I mean, it's a lot of work.
Mm-hmm.
And it's and then of course you have the risk of slashing, etc., right? And then okay, you can get slashing insurance or pool the risk with other folks, but again, it's a little scary.
Mm-hmm. Yeah, a lot of
You know,
factors.
I, there's a lot of factors. I think I have always deep, deep admiration for folks who do it. Um, and now with the flex node, you go, look, as long as I don't do anything wrong, like,
Mm-hmm.
give you bad equations, and of course we have, as you can imagine, fantastic, math to deal with if somebody does.
Mm-hmm.
So I won't go into that unless you want to. But unless I don't do anything wrong, I'm just getting paid for what I did. You
Mm-hmm.
know, if I gave you equations because, hey, you needed them, I had the ability to give them to you and they were helpful, great. If I closed my laptop and I was doing something else, hey, that's okay too. I just, I don't do anything, I don't get paid.
Mm-hmm.
Fair enough, right?
Mm-hmm.
So it's kind of like, again, more like real life. You should be getting paid and rewarded for the useful things you did, not sort of punished for the things you didn't do because you were not in a position to do them. Because.
Definitely. And I love
Yeah.
that. There's been many examples in automotive and physical AI about how inefficient, your car's sitting at your house 90% of the time,
That's
and
right.
you've paid for it. And most people, they know that, they're, even when they're using their computer, the CPU usage, most of it's not being used, never mind overnight, and looking for opportunities to utilize that CPU power that they've paid for. It's at their house, but it's just not in use.
That's right. And you paid for your cable at home, right?
Mm-hmm.
So you paid for your bandwidth. you're sleeping, or you know, uh, unless it's when, in my household, when my husband and I are doing things and our son is also, also playing whatever he is.
Hmm.
If it's, most of the time you have spare bandwidth also. And even if you feel like your Wi-Fi is um, a little clogged up, chances are that you, your cable or your fiber is not.
Mm.
And therefore, why are you paying for it and not getting money for it, and also helping other folks, right? So,
Hmm.
you're getting
Hmm.
money because you're actually doing useful work, that is, not onerous. And it's understandable that, if you lose your cable or whatever, it's okay,
Hmm.
Okay, you don't
Yeah.
get paid during that time you didn't expect to.
Yeah,
Um,
at least you don't have to have all those hard setup costs like that's why I haven't got into Bitcoin mining or these other validator
yeah,
programs, because the upfront investment is just for that. It's like you're going to have a computer anyway to do your daily work, but there's a lot of upfront investment. And talking about earning, can you dive into how exactly that works? If you just contribute a little bit, is there an optimum token that you get paid in, or other crypto or fiat?
yeah, yeah. So we don't have a token currently, and I mean, we do plan on having one at some point, but I don't want to give time frames or anything.
Hmm.
So I'm going to talk more in a general way of the mechanism, right? So imagine that you're a validator, Ashton. You finally decide to bite the bullet even once you went and said, okay, this is really expensive, and my OpEx and my CapEx. Okay, I'll do it. Okay. Um, and then you say, okay, oh gosh, I'm about to miss my attestation.
Mm.
Hey, Muriel, you, yeah, you're right there. Come on, give me a few equations. Like, oh yeah. Give you equations. Yeah, phew, that was great. Thanks a lot. Um, here, I'll reward you, right? And then, the idea is you did you did something which was valuable to you, and I was able to help. We figured something out, right? It's because inherently there's true value.
Hmm.
I did something that helped you, and maybe you were an Ethereum validator, maybe you were a Solana validator, maybe you were a BNB validator. I mean, that's kind of like that's your business. And I just happen to be able to pull equations and give you equations at the right time for what you needed. So, you know, there was real value, and there's going to be, fair exchange of value between us.
Hmm.
Um, this also means that now if you were in a geography where you go, I'm not quite sure that I can do the uptime, maybe you'll be less hesitant, right?
Hmm.
Because you go, hey, look, um, my connectivity has suddenly gotten better because people in my neighborhood are running Flexnodes.
Hmm.
And they're helping my neighborhood. This is great, So definitely when we do our tests, one of the things we see is that, we do tests both with the kind of node distributions that are more typical currently, which are generally sort of North America,
Hmm.
certain parts of Asia, Europe, right?
Hmm.
Those tend to be the more typical um, arrangements of nodes. But we do a lot of tests with those massively geodispersed setting.
Hmm.
Not just the geographies I just mentioned, but Africa, other parts of Asia, South America, and it really, really, it's Australia. It really,
Hmm.
really is stark, how
Hmm.
much better you do. So it also allows all of a sudden a much more inclusive geography in terms of people being able to operate. And of course, the more people can participate, the more these chains can scale,
Hmm.
and the better it is for everybody.
Hmm.
And, going back to the user, remember we were talking about the user and the roads and so on. One of the things that's great for a user is that they may not notice, again, the roads that made the lattice appear on the shelf. But all
Mm-hmm.
of a sudden, it's like, I've got lattice there all the time and it's cheap. This is great. So it's like,
Yeah.
oh, my transaction, it happened quickly and I didn't have to pay a lot of gas. I'm happy.
Mm-hmm.
So these are the kinds of things, that people notice, even though they may not interact directly with some of this infra propagation. They do see the effect and the benefit.
Definitely. What are some of the major milestones coming up? I think 2026 is going to be a big year for
Yep.
Optimum. What are the major things that we have coming up ahead?
Yeah. So the one that is coming up soonest, and I think is one of the most exciting, is in about a month. We will be on Ethereum mainnet.
Hmm. That's
So
big.
we have it. Yeah, that's big. Thank you. Yes, yes, we are excited. And we have been working with a host of just amazing validator partners. I mentioned that was how we did our go-to-market, and they've really been fantastic. You know, uh, just super involved, super positive, super helpful. Um, and people like Everstake,
Mm-hmm.
P2P.org,
Mm-hmm.
Kiln, Block Demon, Nethermind. I mean, the list
Mm-hmm.
goes on and on. Um, and we then go to mainnet, and then that's when the rubber hits the road. Um, in order to have a business, we think it's important, going back to the example we gave before, right? You wanted something, I gave you something that you wanted, and um, you got a return from it, is we need to provide a better return for the validators,
Mm-hmm.
because that's how they stay in business. And if, they're not in business, then bye bye blockchain. Um, so, I mean, it's basically it, right? Like, um, it- um, so it's really, really important to make it so that we improve their business. And, the main indicator for them is their annual percentage yield, right? Their APY. Are
Mm-hmm.
they able to, stake and get return from that staking?
Mm-hmm.
And for us, it's about improving that for them.
Yeah, definitely. Financial incentives are important to make people do things. That's for sure.
Uh, it's also because, you can't expect people to put in that level of effort without,
Mm-hmm. Mm-hmm.
it's too much.
Definitely, yeah. I'm excited to see that EVM mainnet launch. Would love to follow up again. And
Please.
there was many other things that we spoke about that it's like this deserves a whole nother episode by itself.
I
So
would love that. I would love that, Ashton.
looking
Yeah.
forward to it. Thank you so much, Muriel, for all the insights into this, how we can propagate optimally blockchains, and we need that if we're going to drive adoption into non-technical sectors. We need it to be optimized before they adopt and during, and not backtesting it after. So this technology is important. Congratulations so far on all the success
Thank you.
with Optimum, and let's follow up again in the near future.
Thank you so much, Ashton. I would really like that. And as I mentioned at the beginning, really appreciate the invitation. This was a fun chat.